So today we will be looking into the structure of glucose and fructose. So here you are having the structure of glucose. Glucose is having the aldehyde base. It is having aldehyde. It is aldehyde, which is basically aldehyde group is known as C bond O. One side H, which is hydrogen, and other side it should be R. So basically this group is known as aldehyde. This group is known as aldehyde, right? So today we will be looking into the structure of glucose and fructose. Over here I have drawn the structure or the linear structure of the glucose. As you can see over here we are having this. This is carbon number 1, carbon number 2, and carbon number 3. Over here you can see here the OH will come. Okay, on every carbon the OH is on the right side, but on the carbon number 3 the OH is on the left side. So this is basically a trick in order to learn the structure of glucose. So this is a linear structure of glucose. The formula of glucose is C6H12 and O6. So this is basically the formula of glucose. You can see over here, right? So I have drawn here the linear structure, which is this: carbon number 1, carbon 2, carbon 3, carbon 4, carbon 5, and carbon 6. So this is basically this is linear structure, which is present. It is present in the dry form, present in dry form, right? Right, this is present in dry form, but this structure is not stable. It is unstable, right? And when we dissolve this linear structure in water, it turns into a ring structure. It turns into the ring structure. We dissolve this linear structure into the water, then this structure turns into the ring structure. Let's show you a ring structure, right? Okay, so here I'm having, let's see the ring structure of glucose, right? Let's look at this. Okay, we got diagram. Paste this diagram over here. So here we are having this ring structure of glucose. So as you can see here, this is known as carbon number 1. This is carbon number 2. This is carbon number 3. This is carbon number 4. And this is carbon number 5. This is carbon number 6. Actually, over here in this linear structure, the carbon number 5, basically the cleverness is in carbon number 5, the second carbon. This carbon number 5, this OH go to carbon number 1. The OH group goes to carbon number 1 and it reacts with, here you can see the double bond, right? The double bond of the oxygen will make an equal bond form with the carbon number 5. That's why they form this ring. Okay, this ring is basically known as pyranose ring. Now what does that mean, right? Wait a minute, what's happening? Okay, this ring is basically known as pyranose. Now what does that mean actually? This is known as pyranose. What does that mean? Basically pyranose means a ring in which there are 5 carbon plus, like plus plus 1 oxygen, right? So that is known as pyranose. So that ring is known as pyranose. Pyranose contains, like what is pyranose now, which contains 5 carbon plus it contains contain 1 oxygen. That is known as pyranose. And then another ring known as furanose. Furanose. Furanose, which contains actually 4 carbon plus 1 oxygen. That is known as furanose, right? So actually this glucose is how, so you can see this is a ring, right? So over here 1 oxygen is there, right? 1 oxygen is there, right? Here over here we are having 1 oxygen. Oxygen is there, carbon 1, carbon 2, carbon 3, carbon 4 and carbon 5, right? And we are having this one, like we are having this carbon, but it is outside the ring, right? It's not in the ring. That's why we won't count this carbon, we will only count this. This carbon is in a, this is outside. This carbon is basically outside. So we won't count this, we only count these carbon highlighted over here. So basically how many like carbon are there? Like here only 1 oxygen is there, right? 1 oxygen, 1 carbon, 2 carbon, 3 carbon, 4 carbon, 5 carbon. So that's the reason it is known as, this is known as pyranose. This is known as pyranose, right? So now let's look and let's talk a picture of, okay, here from here you can the concept more clearly. I'm having another picture. Okay, so as you can see over here, let's take a picture. Okay, so this is a quite nice picture. Let's see this one picture over here, right? Let's take into this picture and okay. So as you can see, this is open structure. This is the open structure basically, right? Over here, this is the open structure, and here carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, carbon 6 is the structure, and it contains aldehyde. Now we have formed this ring, which is known as pyranose ring, right? I hope I got clear to you. Let's move to another ring which is known as, and the structure which is known as let's get into the structure of fructose, right? So fructose is actually an isomer of glucose. Basically, there's only difference in the aldehyde group and the ketone group, right? Over here you can see this. Okay, here you got the structure, right? The ring structure and the, okay, so here we are having straight chain. I want a straight chain, open chain structure of fructose. Got. Okay, so we are having this structure, right? Let's do this and I'll help you to okay, I'll explain. Okay, this is basically the structure of fructose. So this fructose actually contains a group known as ketone group. This contains basically ketone group, which has it has the general formula C double bond O R, and here it will be also R, right? This is the general formula ketone basically. Or you can say a structure in which there is double bond on the carbon number 2. That is known as ketone, right? Okay, here carbon number 1, carbon number 2, carbon number 3, carbon number 4, carbon number 5, And it says carbon number. So remember one thing, that glucose and fructose both are isomers, right? So fructose and like they are isomers. What does that mean? They have only different structure. They are same, right? So they have the same single. As you can see over here, this is there's double bond on carbon number 2. Else the structure is same on carbon. You can say on the right side it is H, not OH, right? Okay, I hope this is clear to you. Now let's dig into the ring structure of the fructose. Okay. Okay, this is basically the ring structure of glucose. Okay, you can see this carbon. Okay, this carbon. I don't think so. Let me find another one. Okay, basically here you can see. Okay, this is correct. Also correct. Here you can see carbon number 1 is here. Carbon number 2 is here. Carbon 3, carbon 4, carbon 5, and carbon 6. Actually, in this carbon number 5 reads with carbon number 2, right, which is having double bond. Obviously, okay, I always remember this thing that uh, in all, like always second last carbon will react with the functional carbon, the carbon which is having the double bond, right? So right, so over here it reacts, and in the ring there are only 4 carbons. In the ring there are only 4 carbons, and one oxygen is here. Else carbon number, you can see over here, carbon number 1 is out of ring, carbon 6 are out of ring, right? So you can see this ring is known as furanose. Furanose. This ring is known as furanose. It contains 4 carbons in the ring and 2 carbons out of the ring and oxygen. Let's count OH in this, right? OH, second OH, third OH, fourth OH, and right. So in like glucose, there are 5 OH in the structure in 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 a ring structure basically, right? But let's look in the fructose. There will be 6 OH. There will be 6 OH. OH number 1, OH 2, OH 4, OH 5, and where is one more OH? 1, 2, 3, 4, 5. Where it is? Okay, basically they have mixed over here. Here OH will come basically, right? And then there will be 6 furanose sugar. There will be 6 OH, while in the glucose there will be 5 O. Right? So I hope the concept is clear to you. And these concepts are quite important. MCQs they have been asked in many past papers. As you can see, you check them. Get free. These all MCQs are included in that paper. So I hope this is clear too. If any have query, you can ask me.